So is it the best time to learn something over these quarantine days?
Yeah, so it might not be the best time to learn because everyone is a little bit elsewhere occupied. I think even kids that are trying to learn at home, they're still stressed. Everything is very uncertain. But then again, if you're stuck at home anyway and you want to do something sensible, then you might want to try to learn programming. So hopefully if people have the mental space to learn something, then it's best, of course, if they learn programming.
Mm-hmm. Okay, so I'm looking forward to hear what you are planning to say.
And you're seeing my screen, right?
Yes, we can see your screen.
Perfect. Okay, let's go then. Because what I want to talk about today is a new programming language that I've designed to teach children programming. It's called the Hedy programming language. It's named after film movie star Hedy Lamarr. And I was going to do this talk actually at a conference 2 weeks ago, but the conference was cancelled. So far I've only presented my new programming language in a YouTube video when no one was watching. So it's actually nice to do it now when at least some people are watching through remote participation. So first we'll talk a little bit about the background of this programming language, because a while ago I started to teach programming to children in a Saturday club for kids. I started to teach programming to children, and I thought it was going to be very easy because I thought, well, I can already do programming, so how hard can it be to teach programming to kids? But it turned out to be very hard, actually. And what I realized is that as a programming community, we have a weird relationship with teaching children specifically. So I want to take you through some of the things I read in books for programming for kids that I bought. So I will show you a few of the books that you can buy in the shop. The books will be in Dutch, but there will be an English translation underneath every snippet. And from these books, you can see the perspectives that we as a community have on teaching children. Here's one, for example. This says, the best part of programming is finding a mistake. That very much says something about our culture. It doesn't even say the best part is fixing a mistake. It says the best part is finding a mistake. So who thinks that? I don't even really think that. I don't like finding mistakes. Ooh, the chat is coming. I'm not sure if this is for me. No, this is not for me. That's okay. I don't even like finding mistakes. I prefer seeing no mistakes. So if we say the best part of programming is finding mistakes, that might attract people that like the puzzly nature of programming and that aren't very worried if something isn't working. Here's another one. Programmers only learn from making mistakes. So again, making mistakes in programming is seen as central to learning. If you make a mistake, well, the only thing you can do is learn from it, which also, of course, isn't necessarily true. The result of a mistake can also be I make a mistake and then I don't know how to fix this mistake and now I don't like programming anymore. Like I'm out. I have had this experience a while. Of course, I have always come back, but there were definitely times of which I thought, I know programming it's just too hard. I don't even like this. Here's another one. And again, these are books marketed to young children, 8, 9, 10-year-olds. You will fail often and it will be frustrating. Of course, it's true. Learning something new is frustrating and you will fail often, but centralizing this as part of the experience, again, says something about our programming community. If you have a book that is soccer for kids or horseback riding for kids, most likely they will not say, oh, if you want to learn horseback riding, this will be hard and you will be frustrated. It says, oh, I know, let's do it together. With a little practice, you can do it. This, again, very much centers the experience of it has to be painful. Learning to programming, it must hurt. Otherwise, it's not really valuable. This one says, never be afraid to mess around and experiment. So again, it is this tinkering feeling that you have there. And break the rules. So in general, people that know me, they might know this, that breaking the rules, I think it's good life advice. Absolutely, you should here and there break the rules. But this book is about the programming language Python. And for people that have never seen Python, this is Python from the same book that says break the rules. This says, look, a colon goes there and a rectangular bracket goes there and a quotation mark goes there. Python is so precise that if you put a space in the wrong place, then Python will crash. So on the one hand side, it's break the rules. It's very much this tinkering and trying stuff out. But you have to know what to try out. Because if you try out the wrong stuff, like putting a space in the wrong place, then everything will break. And most importantly, it's fun. Again, look at what this doesn't say. It doesn't say the most important thing about learning to program is you can get really rich and it's a nice career, or programming will allow you to build a cool app on your phone that you want to have, or a game, or an animation. No, the most important thing is fun. So this is how we present programming for children to children. We say, well, you'll make many mistakes, but a mistake is fine. You can just learn from a mistake, and it's going to be very frustrating. Break the rules, but also follow some of the rules. And if you're not having fun, you're doing it wrong. This very much shows the perspective, I think, of the programming language community as a self-taught community. People that, like me, growing up, I learned programming when I was 10, 11, 12. People that, you know, went through the mistakes. They did the rite of passage of fixing all their terrible mistakes. They grew up to be programmers, and they are now telling children that this path of plowing to all the mistakes and still enjoying this puzzly nature, that's the way to go. And then with that, we create the same community over and over again. This was very much my vibe when I started to teach children. This is like 7 years ago. I also thought, yeah, you know, you just let stuff happen. Kids just experiment and they will find their way. If there's a mistake, we can fix it together. Very much this exploratory way of thinking. So literally, I bought these books in the bookshop, handed them out to the kids, and I was like sipping coffee in the back of the room, feeling really good about my service to the community. Hey kids, if you have a question, just let me know. Everything will be fine. So unsurprisingly, everything wasn't fine. The kids were really, really struggling. And I was also struggling. I didn't know why they didn't get it, why it didn't stick in their brains. I really remember myself saying stuff like, yeah, but I explained this to you 1 week ago. How do you not remember this? How is it possible that I have explained something to you once and you don't remember this? This really also frustrated me. And I thought, I need to know more about how people learn to be able to really get knowledge in their brains. Because clearly this way of just having them explore and explaining why there is a mistake and helping them fix the mistake at the spot is helping them fix the mistakes now, but it's not sticking in their brains. So I really wanted to understand then, well, how do people learn? And one of the things that I learned is that the human short-term memory can only hold between 5 and 9 items. So your brain at the same time can only hold 5 to 9 items, which is really very low. It's sort of a surprise that I can sit here and wave my arms and also speak, because our processing memory is really, really short. And just to have you experience this, we'll do a little quiz where I'll show you a brief sentence, just a few seconds, and you have to memorize the sentence just to see how little room there is in your brain. And every sentence, it will just be there for like, I don't know, half a second or something. And of course, no screenshots, and don't take pictures with your phone. So I can, of course, not check this remotely. But the idea is that you participate and you don't cheat. Okay, so I hope you're ready for the first sentence. Let's go. So probably that was very, very hard. Maybe you're saying like, oh, this isn't fair. That isn't even a sentence. They aren't 3 letters. This isn't fitting in my brain. So here's another one. Same length of the sentence. And this will already be, I will promise, slightly easier. There we go. So this might have been doable. Still very hard, but easier. And now for the third sentence, I'm sure everyone can do this if you don't miss it by blinking. Same length, same number of characters. Here we go. So that was quite easy, right? You just immediately read it and you can still remember that the sentence was cat loves cake. Why is this so easy? Why in your brain you can process this first one, but the second one and the third one are way too complicated? That is because what your brain is doing, of course, you're not remembering all these individual letters. You're not saying half a circle and a circle with a squiggly mark and then a Catholic cross and then a long stripe. What you do is you read the words at once, and then you remember just the word cat, just the word love, and just the word cake. These are 3 things, and that will easily fit in your working memory that can have 5 to 9 items. This easily fits. And these things are called chunks. The small snippets of information that you store in your brain are called chunks. So if your information is presented in such a way that you can easily chunk it, for example, for people that are proficient readers in words, then you can very, very easily remember this. The flip side of this, of chunks, is that also you can have too many chunks in your brain. So for that first sentence, if you were really playing along and you really wanted to remember that sentence, you store it in your brain and you almost feel it like in your muscles here. You go like, oh, a circle with a dot and a stripe and a sigma reverse, and then it builds up, and then at one point your brain is full. And this fullness is called cognitive load. If you are overloading your working memory, you experience too much cognitive load. So then I started to get interested. I was like, cognitive load. Maybe the children in my programming class are also experiencing too much cognitive load. How can I make this better? How can I lower cognitive load? How do other fields do that, like math and language? How do other fields manage cognitive load? So let's look at math, for example. Imagine a kid is learning math. What do? You do lots and lots and lots of small calculations. So 3 plus 4, and then you do this 100 times or 1,000 times in school. You memorize all these small snippets, and these things become chunks in your brain. If you've acquired this skill of little calculations, then you can move on to bigger calculations. So now, here we are doing 414 plus 87. The first step of this would be to add 4 to 7. If I'm still doing that like this, 1, 2, 3, 4, oh, and now 7, 1, 2, 3, oh, that's very hard. But I can rely on the chunks. I'm like, oh, 4 plus 7, I've done that many times. That's 11, oh, carry the 1. So because 4 plus 7 is a chunk, we can easily retrieve it, such bigger calculations actually get doable. They would never be doable if we hadn't started at a lower level. And the same is true for language. How do we teach a language to children? So imagine 6, 7, 8-year-olds, they're just learning to read. What do? You don't give them the whole of Shakespeare or Harry Potter at once. You don't say, hey, here's the alphabet, A to Z. You just have to remember this 26 letters in most cases. Here's a book. Well, you know the basics because you know all the letters. It won't work. You need lots and lots of steps. And the rules also change because first you say, well, just produce some letters. We're already happy if you're producing letters. And then we say, okay, so you have the letters and you can create some words. From now on, every first letter of the sentence will start with an uppercase letter. Kids are like, okay, fair enough. Next one, oh, from now on, now we add a period after every sentence. It's like, okay. And then you know what you can do now that you can end the sentence with a period. Now you can split sentences over multiple lines. So you break the connection between a line and a sentence, because initially in the brains of children, there's no difference between every line is one sentence in books for early kids. So you build up the rules gradually. I would like to say, thanks to Kevin's lecture before, I would like to say, like Sweden, when they changed calendars, they didn't do it everything at once, but they did it little by little. I really like that example. I'm totally stealing it. So then let's look at programming. How does programming manage cognitive load? How do we teach programming? Well, we give children Python, for example. Look at this. This is like one of the first programs you might be doing in Python with kids. It's just 1, 2, 3, 4. Well, actually, I think it's 0, 1, 2, 3. How many items are there? Well, 1, 4, I in range, open bracket, 4, closing bracket, colon. Then I didn't even count the space in the second line. Print, open bracket, I, closing bracket. I'm already over 9 easily. Clearly, all these elements will not fit in the brain of a learning kid because we, experienced programmers, we see this like we see cats or like we see loaves. At once, you immediately see what it does. But all those separate elements just register with children that are learning as separate elements, very much like we did with the first sentence where everything was unknown to us. So this frustrates kids because their brains are overloaded. And then it frustrates teachers because they're like, this is so elementary. This is so easy Python. How do you not know this? So then I started to compare these things. I was like, in programming, we teach everything at once. But then let's look at language. We don't do everything at once. Programming starts at the end by having all the rules. All the real rules are immediately there. Why don't we simplify that? Why wouldn't we say, well, before you do real sentences, you can do a for loop without the colon. That's just one element. We just remove it. We don't need it. We can do it later. Like we remove periods if we have sentences for children, for early children. And then before that, we can say, why deal with the indentation? Why not make it simpler and we just have every command is one line? And then before that, you could say, well, why do we need the for, I in range? That's only adding extra clutter. We could just say, well, for 4 times, repeat, print something. We could start easier and then gradually build up until all the rules are there. So I guess you see where this is going, because this is actually the programming language that we built. So I'm gonna, it's online, so you can check it out after the meetup. I'm just gonna briefly show what we have now. So this is the programming language, Hedy, that gradually builds up the syntax of Python until children can do Python. So it's already online at hedy-beta.herokuapp.com. So you can try it out. And this is how it works. So this is the first level. You can just run code here. And as you can see, it's just printing. And you can print anything you want. You don't need brackets. You don't need quotation marks. No syntax yet. You can just print whatever you want. And what you can also do to make it a little bit, more interesting is you can echo something. So this asks, what is your favorite color? And then it echoes back the answer to you. So if you run the code, then what is your favorite color? You see green and says, so your favorite color is ... green. This shows the basics of programming. It shows that there is such a thing as syntax. You have to type something, but also you have to click here, and then the output appears there. These are also sometimes things that confuse children that don't have good computer proficiency. They don't even know where to type. They don't know where to click. So they can now experience the first steps of this programming experience in a very limited context. And then if you're done, you can say, okay, now I want to go to level 2. In level 2, we add variables. All level 1 commands still work, but now you can also have variables. And look at all the parsing magic that we created. You don't need quotation marks for strings. You can just say, name is Hedy, print, welcome name. So you run the code, and it says, welcome Hedy. Like, look at all the magic. You don't need to tell the compiler that this is a variable and this is a string. We figured it out in the background. We parse everything, and we do, of course, to go a little bit technical here, you do lose the fact that now the grammar isn't context free, because first you need to make a lookup table. But who cares that we are doing some magic? Because this magic makes it way easier for kids to create something. And then in the next level, I will not do all of them, but just one more, because I really like this step. In the next level, and I'll show you why you need the next level. So now what you might want to do is say, hey, your name is Hedy. So you might print something like this. Your name is name. You might be interested in doing this. And of course, this doesn't work as you intend, because now you get your Hedy is Hedy, because name is the variable and we place it everywhere. This, what I very much like about this, is that this also creates the need for syntax. So rather than saying every string, you must use quotes because it is the law and otherwise you get a compiler error, we explain to children, we take them with us in reasons for syntax. Very much like if you learn language, we say, well, a period is easy because then you can split sentences over multiple lines. We create a problem. Now we have the problem that the word name cannot be used because we already defined it as a variable. And then you want to go to level 3. Now we're at level 3, and now from level 3 on, you need to use quotation marks around words that you want to print. So you say, welcome, hello, welcome to Hedy. This now prints as the string. And now you can make this sentence that you previously couldn't create. So now you can say, my name with quotation marks is, and then the variable. So now the word name is freed up again. So I think I really like this because children now understand why there is a difference, because they've seen how a programming language looks like if it doesn't have this difference. And that's pretty not fun, because then every variable name cannot never be used as a word anymore. So we've now implemented the levels up to 6. So at level 6, you already have repetition and conditions. So you can already create stuff that's pretty nice and that's interesting. So if you want to check it out, it is available already in English, also in Dutch, and super nice volunteers translated it to Spanish. And then you're like, oh, but I don't want to program. What I actually want to do is I want to contribute to this amazing programming language, for example, by translating it to Lithuanian or German or other languages that you might know. So it might be interesting for you to know that Hedy is entirely open source, and we are now deploying almost every day. New levels and new features are being introduced. So if you want to help, we are entirely open source and we are available for kids to try out. And that was my talk, but let me go back to my slides again so I can share some information. So I'm on Twitter as well, and my handle is super easy because it's just my first name. My website is Felienne, myfirstname.com, and if you go to felienne.com/Hedy, then you can go straight to the programming language. You don't have to type the whole long URL. If people are interested and they're maybe bored because they're in quarantine and they want to listen to more of my stuff, I'm also one of the hosts of the Software Engineering Radio podcast. And that is on iTunes and on Spotify, where we interview people from the software engineering world about databases, programming languages, frameworks, all sorts of things. And we have new episodes coming out every week. That's it.
So thank you, Felienne. And we have some questions. So Justinas wants to ask something.
Hello, Felienne.
Hi.
I come myself from a Saturday programming school when I was 9, I think. That's where I learned my first programming stuff. And we used Logo. Have you heard of it?
Yeah, I definitely heard of Logo. Yes.
My question is related to that a bit, because Logo itself, I had a wonderful teacher. She is, by the way, is a lecturer at Vilnius University. I believe she might even contacted you by some manner. Maybe it's Valentina Degiene.
Yeah. I've spoken to her in the context of the Bebras competition.
So, well, she is kind of famous for teaching kids programming. And what I wanted to ask here is, why haven't you adopted some of the visual things for kids? Because your language, Hedy, mostly uses console, and I find it pretty dull for children. I mean, yeah, there is still magic you can do, but well, you know, what do you think about it in general?
Because, yeah, so actually, it's a really good question, and we have considered to introduce some of the drawing features in this programming language as well. The reasons that we haven't done it so far. So, as I said, it's still very much under development. So there's no reason why we couldn't still add this. The reason why we haven't done it so far is because, well, it was easier this way, and also we want to present Hedy as really an intro into Python. So kids might have done Scratch before, which is sort of modern day Logo. And the reason that children often go from Scratch to Python is that they want to have a textual language that looks more adult, more grown up. Because programming language for children like Scratch look a bit childish. And if children are 10, 11, 12, then they want something that is more real. They want to use tools that they see as adult tools. They do not want toy tools. So that so far was the reason that we thought, let's not include drawing tools, because what children want in the path towards Python is something that looks like an adult could use it, like you could use it for serious stuff. So that was our reasoning. But it is open source. We use the Sculpt Python library in JavaScript, which also has a feature for Turtle. So like fork our repo and add it, and maybe we want to add it to the real project.
And the next question is regarding the translation. I would like to really see if I could help to translate it to Lithuanian, at least for our Lithuanian kids to try out. can you maybe guide a bit? Have you some APIs for that in your code, or I don't know?
Yeah, we actually, well, I think I could show you. So we have in our project, we have a contributing.md, and this also explains to you exactly, this tries to help you what the files are that you need to translate. So the easiest thing, this is at least what the people have done that were translating the Spanish version, is this is a JSON file. You simply copy paste the English text in the JSON file, and then you translate it in the file. So then you immediately have the right structure. But the instructions are in the contributing file. And of course, clearly, if you need more help, then reach out to me. My contact info is on the final slide. Would be lovely if we have it available in more languages.
Yeah, I think I will have a look at it. And one more question related to that. Since you mentioned that you get a source file all in English for translation, so I don't know, just an idea. Have you tried like automated translation with Google or something like that?
Yeah, so I haven't tried it. So probably I should only try it for languages that I do know, because the machine translation isn't really very
yeah, I understand,
reliable.
but you know,
and also sometimes you have to make sure that the code also properly parses. So for example, in Spanish, we didn't support letters with accents, because I didn't think of this, because Dutch doesn't have it. And then people translated it to Spanish, and then it turned out that we needed to update the grammar to also include letters with accents. And for example, a thing that machine translation could do is accidentally translate an example in which a keyword is present. So something like print wouldn't really work in the first level, because then the parser gets sad. So you should also sometimes tweak your examples a little bit to not accidentally create code that doesn't compile. So there might be some tricky situations, but it is a good idea. And definitely, if you want to translate it yourself, you could use machine translation and then do the manual fixes.
Thank you.
Yeah, thank you for the questions. I think that's all.
Well, I also saw one in the chat, if you're okay with that. I think someone said, like, this might also be valuable for adults. So I definitely think this is true. I can give a brief answer. We very much aim this at children, but we do think that novice learners that are adults, even though they might not benefit from an interface that's made for children, they might still very much benefit from this stepwise approach in order to not be overloaded for cognitive load. So it's definitely something that isn't necessarily only useful for children. We're just aiming towards children because there are many children, and the earlier we get them to program, the better.